Ethered kinematic viscosity of V sub ethered equals 6.24 times 10 to the minus 5 meters per second, or meters squared per second. The value, the value Tm equals 1 second. The design parameter value of the interferometer and the calculation parameter, the terms numbers of a series AP equals 0.015 meters, A or alpha sub H equals 0.0367 meters, L sub P equals 0.48 meters, lambda equals 6.5 times 10 to the minus 7 meters, and K equals 4. In this case, the measured value of the ether horizontal component velocity will be defined as follows. WH equals approximately 525 D times sub D. Welcome back, Toby.
You guys' internet makes my soul frown.
Yeah, I don't know. All of a sudden, over the last couple days, it's kind of weird.
Well, it's probably got nothing to do with the truth you're hosting over here and the stuff that's happening.
Yeah, it couldn't possibly be AT&T. So where were you? I thought I had found you, but then now I'm not so sure.
So if you type in parentheses 42, you will get you'll get where we're at.
Boom.
Nice.
So right here,
Yep.
you want me to take over?
If you want.
All right, let's calculate the minimal value of the ether drift velocity, WH min, which can be measured with the manufactured interferometer, i.e., we shall determine the instrument sensitiveness. In the part, the interferometer test is marked that the minimum value d min, which can be digitized with a selected I fragment and scale d min equals to 0.05, then with the expression 42, we shall receive WH min equals to 26.25 meters per second. Let's determine the ether stream regime in the interferometer tubes at WH equals WH min. For this purpose, with the expression 4, we shall calculate the minimal value of Reynolds number, Reynolds minimum, or Reynolds min, for the tube with radius A sub P equals to 0.0105 meters, in which the ether with the viscosity VEA equals to 6.24 times 10 to the negative 5 meters squared per meter squared second 10 to the negative 1 moves. Let's receive Reynolds min is approximately 8834. According to the requirement of equation 3, it can be written down that Reynolds min is greater than Reynolds C. Hence, at the ether drift velocities WH greater than or equal to 26.25 meters per second, the ether stream turbulent regime is possible only in the interferometer tubes. The optical interferometer tests and test results analysis give the basis to consider that the hydrodynamic description of the interferometer operating principle reviewed above is adequate to the imaginations about viscous ether stream in tubes, and the manufactured interferometer is suitable for the ether stream velocity and the ether kinematic viscosity measuring. The measuring methods. The interferometer was disposed in the country settlement at the height of approximately 100. Oh, there we go. Or that was the other. Never mind. We were talking about Kharkov earlier. The other one. I guess this is still probably Kharkov, right? Almost for sure.
Yeah. Kharkov is
wasn't
that high above sea
there.
level. So yeah. Yeah, there you go.
13 km from Kharkov.
Shout out to Kharkov.
Shout out to Kharkov. Have fun with the volcanoes. Northern suburb. Approximate height of approximately 200 meters above sea level. Is located westward apart 1.7 kilometers. 2 points were arranged for measurements. The distance between them was about 15 meters. On the point number 1, the interferometer was at the height of 1.6 meters above the ground surface. On the point number 2 was at the height 4.75 meters. 2 points available, which are located at different lengths, are practically the same point of terrain. It is required for the observation of the height effect. The measurements of the points number 1 and number 2 were performed in the open air. The point number one, the interferometer was in the surrounding tree's shadow and was not exposed to direct solar radiation affecting within a light day. On the point number two, the interferometer was mounted in an umbrella shadow. In winter time, the interferometer was transferred to Kharkov. The point number three, or approximately 30 meters above the ground surface, or around approximately 130 meters above sea level, was arranged in the upper level facility of a bricky house. On the point number one, the measurements were carried out in August of 2001. On the point number two, in August of September, October, and November of 2001. On the point number three, in December 2001 and January 2002. The measurements were carried out cyclically. One measuring cycle lasted 25 to 26 hours. 2 to 4 cycles were performed within 1 month. Each cycle contained the following parameters. The interferometer was mounted on a selected point so that its rotating plane was horizontal. After installation, the interferometer was kept in new heating environment within 1 hour. The instrument was stored in the facility. The measurements were carried out at each whole hour of stellar time. One readout of the stellar value was performed under the following schema. The interferometer longitudinal axis was mounted along a meridian so that its illuminator was turned to the north. The further procedures did not differ from the interferometer operating procedures which were applied at the final stage of the interferometer test. After the interferometer dynamic regime termination, the observer registered the maximal band's offset value d times Tm as the measured value. The band's release time to the original position was registered and metered. The interferometer returned to the steady operating regime. The instrument turned to the initial position. As a rule, 5 to 7 readouts were done during one measuring time of approximately 10 minutes. The readout mean value was accepted for the measured value of d times s, where s is the measuring stellar time. The processing methods of the measurement results. The measurement results processing included the following procedures. Values calculations of the ether drift to horizontal component velocity WH. A daily course of the ether drift velocity. Let's go ahead and get some highlights here.
Although the emphasis in your voice is carrying it a really long way. The effort is going far, dude. For real.
Dude, we had to increase the passion level after you
Right?
called us out, bro.
Dude, like, honestly,
You came reading when I'm sick, bro. I'm like making it through, and you're like, you guys dead in here?
you sounded like you wanted to die rather than finish that fucking sentence. You were like, tell me, did you want to read for me, please? I was like, oh shit. I'll read what's going on. Poor guy. But yeah,
Is that what it sounded like?
Yes, exactly that. And now Toby's like jovial and like interested. Like it clearly is fake, but it's better than it was. So.
Hold on, I got you. Hold on, I got you. Where we at, Toby?
We're right here.
All right. The ether drift velocity daily course average during the year epoch WHS, so the ether wind on sidereal time. The daily course of the ether drift velocity averaged for the whole time measurement series is WH in parentheses S. So WHS is ether wind sidereal time. The mean square value deflection of the ether wind from its mean value of, what is that? Dang it. I should have studied my flashcards. Anyway, yeah.
Sigma.
W. Sigma, there we go. Sigma W. The measurement results were introduced as the measured value tables DS, so D sidereal. So the values WH calculated with the expression 42 were brought to the same table for each hour of the stellar day for such number consequence obtained for separate stellar days described. A daily course of W is the ether wind on sidereal time. The mean values of the ether drift velocity and the values sigma W are calculated for each hour of the stellar day with the following known expression of equation 30. And there we have equation 43, which leads us into equation 44, where rho is the value of the ether wind obtained during the whole measurement series. So the summation of the sidereal fluctuations and all that, or against sidereal time, gives you the total value of the ether wind.
Right.
Damn.
Alan,
Go ahead.
Alan, that's the W's with the bar over it. That's the mean sidereal value. It's basically, it's a weighted average well, it's an average. And the sigma W is actually the standard deviation.
Oh.
Sigma was
So
close.
so that bar on top, what was that again? That was the average of that?
Average or mean. Yeah, it's computing the average. And then,
Okay.
so he's basically just doing the statistical computations to give the
Yeah.
average over the sidereal time and then the standard deviation for that value.
Nice.
That's awesome, actually.
Yeah, thank you, Eric.
And
That's fantastic.
Oh, you're welcome.
You say I can't listen to these boys struggle. They're good-hearted, but man, are they making a fool of themselves? Hold on, I can open my mic.
dude, he's a good man, and we thank him for
Right?
it.
Good-hearted.
The confidence intervals of the measured values were calculated with the known methods explained for the example in the work of citation 30. The calculations were performed to the estimation of the reliability equal to 0.95. So that was that threshold that they had determined when they would be good to go. And the measurement results, the measurement series results held since August 2001 till January 2002 are presented, and the work 2,322 readouts of the measured values have been performed during the series. The distribution of the readouts per month of the year is shown in Table 1. According to the research problems, we shall consider the work results along the experimental results of Miller from Mickelson and at Cleveland and Miller at Mount Wilson. These four experiments have been performed at various points on the globe with three different measuring methods: the optical interferometer of the first order, European Ukraine 2001 to 2002. This work, the radio interferometer of the first order, the same thing in 1998 to 1999, done by the same gentleman. Optical interference of the second order, northern USA. So this is Miller here. So 1925 to 26, and then 1929. The measuring method action were applied in the above mentioned experiments based on the wave propagation regularities in the moving media responsible for these wave propagations. What's all the moving around, Toby? Is there some significance to this experiment that we just read?
Yeah, well then I'm also just pumped because we have those other couple of new random old Galaev papers.
The old stuff. Let's see. So
Which
that allows.
Oh, here it is.
Ooh. Oh. Oh.
But this is not necessarily, I think, what she's talking about here, or what he's talking about here. I mean, sorry.
Nice.
98 and 99.
How dare you misgender an ether speed researcher, man? That's just
Well, some random translation called Galaev a she somewhere, and then I got curious, and then I went and found a picture of him.
and it was decisive.
Yeah, it was only
it's
emphasized with
decidedly a
his
dude.
pronouns.
Yeah.
So the development regularities of this is where we are, right?
Yeah.
I can take over. The development regularities of viscous medium streams, fluids, or gases in directing systems are used in the work measuring method. The measured value is proportional to a velocity differential of the ether viscous streams in two tubes of different section with the original hypothesis. This differential value is proportional to the ether stream velocity, the first order method. The experimental results measuring method of 1 through 3 of citations 1 through 3. The regularities of viscous medium streams near the surface partition are used. The measured value is proportional to a vertical velocity gradient in the ether stream near the Earth stream or near the Earth's surface within the original hypothesis. This gradient value is proportional to the ether drift velocity, the first order method. In the experiments of 7 through 9 and 10, Michelson's cruciform interferometers were applied. The measured value is proportional to a velocity differential of wave propagation in orthogonal related directions in the ether drift stream within the original hypothesis. This differential value is proportional to the ether drift velocity, the second order method. In the figure 8, the experimental results referring to August are presented. On fragments of this figure are shown accordingly in figure 8a. This work's results. In the figure 8b, the experiment results. The figure is published for the first time. In figure 8c, the experiment results of citations 7 through 9. The ether drift velocities WH in kilometers per second are pending on ordinate axis. The stellar time S in hours is pending on abscissa axis. Each of figure 8 fragments illustrate the variations of the ether drift velocity within a stellar day, WH times S. So figure 8 fragments. Figure 8's table 1.
Did you guys note that the people who did this called it ether drift from way back when? That's not a cool colloquialism invented by Alan, even though it sounds just like it. Because someone was like, "What about that ether drift?" I'm like, "Well, we don't call it that. That's what the G's who discovered it called it." But whatever.
Yep.
It's all over the paper.
What Miller? Here's Miller, man.
Yep.
1930.
That was the first time I saw it. Right, I was like, "Oh, that's a nice sounding phrase to describe what it is." But all the people use the same like terminology when they were describing. All the papers read that way, right?
Everyone called it that, yeah.
Right. It's like globularists. They all knew the lingo.
Yeah. Oops. All right. So, figure 8, variation of ether drift velocity within a day in August. There you go. There's a space effect.
Indubitably. So, a translation of motion that matches sidereal time, where the fluctuations reach their minimum and maximum dimensions corresponding to sidereal time. Sorry.
It's crazy. That's actually absolutely crazy. Couldn't possibly be an ether wind.
It's such the well researched, like detailed, explored. Like it's so nice to find all this wonderful work already done.
I don't know. Definitely looks like Earth rotation to me.
Like, imagine if we had to go do all this, dude, to prove the Earth didn't spin.
Don't you guys feel when the Earth speeds up like that at about 4 a.m. every day?
You know when the sun rises and the Earth speeds up faster? Wait, what?
Dude, we rotate into it or whatever, right? Or,
you rotate backwards faster than the speed of sound. If you did that, you'd never catch it, dude. You'd purposely chase the sun around the fucking...
Dude, oh my god. That's crazy.
Notably, the same thing Maurice Elias found with his pendulum. This looks so familiar.
Yep. I can't believe that their method was, I don't know, just ignore it, don't answer any questions, and don't tell anyone about it. Maybe it'll go away.
All right, so where were we?
Well, you know, if they're getting away with just having the pilots assume that the Earth is stationary when they're trying to land, and that it can't be stationary and moving, right? They can't assume that it's stationary if it's actually moving. So they're getting away with that. Like, of course, the ether wind is going to be nothing to avoid.
All right, let's knock this out.
They got guys saying that it'd be just the same if it was spinning as if it were Come on. Anyway.
Right. Now you're good. We're about to knock this out though.
Each-
And,
Right.
Each of figure 8 fragments illustrate the variation of the ether drift velocity within a stellar day, WHS. The experiment results are presented only by the authors of work of citation 10 as ascertaining of the velocity maximal value measured by them in relation to the movement of W approximately equal to 6 kilometers per second. That is not allowed to show this experiment results in the figure 8 as the daily dependence WH of sidereal time in the figure 8. The measurement data averaging results were presented with the thick lines, which are obtained in each of the experiments during the August epoch, meaning mean results. The separate observations measurement results during a separate day are shown within the lines. The dates of separate observations are specified on fragments. The separate observations on fragments of figure 8A, figure 8B are selected from the performings, which had the date proximate to the date of separate observation of figure 8C. Fragment in which during the day had no skips during the measuring. The date discrepancy is stipulated also by the fact that the systematic measurements in the work began on August 14th of 2001 and in the experiment of 1 through 3 on August 11th of 1998. Okay, so 1, 3, 8, 9. Okay, so 8, 9, 1, 3, and these are both 1, 3, A and B and C. Crazy. Different experiments, same sidereal time fluctuations during August.
But dude, it's probably the temperature.
That's so cool, man. The positive measure. What's that?
The real people back then who was following this were like, "Oh, it's a good thing they're gonna figure it out." And they're like, "Oh no, it's temperature. It was temperature, honey. No, none of it counted. Yeah, all 5 million. Yep, all. Yep, doesn't matter.
Now
Okay,
put it in metal and
You
measure
know what
it
I mean?
again.
Like, what the fuck?
Put it in a metal shielding and measure it again.
Put it invert. Turn it upside down. Can you put it underground? How about you drape it in a sheet? Is that all right?
The positive measurement results given in figure 8 illustrate the development of the anisotropy effect, or the anisotropy effect, the ether drift required effect. In the work and in the experiments 7 through 9 and 10, the anisotropy effect was discovered by the optical interferometer rotation. In the experiment of 1 through 3, the opposing radio waves propagation was applied. The similar nature of the ether drift velocity variation within a day in August epoch unite all 3 fragments of the figure 8. The first minimums and dependencies, WH is what again?
WH is the ether wind.
Ether wind, thank you.
Just the natural ether wind. Yep.
So the ether wind according to sidereal time are expressed clearly in all 3 mean results. In the work of figure 8A and in the experiments of 1 through 3, figure 8B, temporary position of minimums is sidereal is approximately 3 hours. In the experiment 7 through 9, figure 8C, the temporary position of the first minimum of sidereal is approximate to 0.8 hours. Such discrepancy in the position of these minimums is about 2.2 hours. An explanation has not found yet. The ether drift velocity wait, what? So there's some discrepancies. That's interesting. Okay. Guess you can kind of see it there. Yeah. Huh.
I mean, they're like the most sensitive instruments
Yeah.
that we know of, that I'm aware of. Like, I don't know. Seems
But
like
then
if the wind farted.
also, it could just be related to the greater cycles, right?
The greater maximum, meaning the electromagnetic ionized field that it's measuring is so excited that it
Yeah.
measures erroneously, goes
That's-
too far
well,
one way.
I think it's real. I think it's relative to the cosmos as a whole. So if we're not on the same part of like the epochal cycle or whatever, then it's not gonna
I, th-
be
I thought that
exactly
was
the
if
same.
you detected orbital velocity. That whole like solar system stuff is dependent on a bunch of other stuff that never got.
Hey, Eric, you know what wavelength this laser was?
Oh,
For this experiment, no. On the other one, I know what. Well, it was they didn't use lasers. That was radio waves. But no, I haven't been looking. I haven't looked at this paper as in much detail as the other one.
Okay. Yeah, I thought we read over the wavelength at the beginning. Can't find it.
So
Anyway.
the ether drift velocity magnification is observed during the consequent 2 to 3 hours. Further, the plateau sites with rather small variations of the ether drift velocity in time are noticed on all fragments. The greatest duration of the plateau site was observed in the experiment of 1 through 3, figure 8b. That can be explained by arranging peculiarities of a radio frequency spectral line on terrain. In this experiment, the radio frequency spectral line is declined from a meridian on 45 degrees to northeast. The variations of ether drift apex azimuth, as well as any star azimuth, occur symmetrically to a meridian line within a stellar day. If to take the apex coordinate values into account, according to Miller, let me pull my thing up.
Delta.
Delta is approximately 65 degrees. Alpha is approximately 17.5 hours. The ether drift azimuth in this part of a stellar day accepts the values which lay in the northeast direction, i.e., the direction close to the direction of a radio frequency spectral line. In this case, the angle between the ether drift azimuth and radio frequency spectral line direction has minimum values. Accordingly, at the interval of 12 to 16 hours, the ether drift radial component velocity directed along a radio frequency spectral line keeps rather high value despite of the apex height magnification astronomical coordinate. Such arranging peculiarities of the radio interferometer on terrain can explain the relative dependence variance ether drift of sidereal time at the interval of 12 to 16 hours in comparison with the same dependencies shown on the other fragments. In the work of Figure 8a, according to accepted measurement methods, the optical interferometer was located along a meridian. As the variations of the ether drift azimuth within one stellar day occur symmetrically to the meridian line, in this case, the plateau site duration should be less than in the experiment of 1 through 3, and less than the experiment of 7 through 9, in which the ether drift azimuth variation was considered by the corresponding rotation of the interferometer. It can be seen in Figure 8a, the mean result of the work, that the sites with rather small values of the ether drift velocity extended in time take place within a day. Noticeable bands offset of an interference pattern was not observed per a separate day on such sites. In these cases, the ether drift velocity was lower than the interferometer sensitiveness, i.e., the ether drift was less than 26 meters per second, that was used for the interferometer test, the purpose of which is given in the above-mentioned part, the interferometer test. Systematic character of experimental investigations of this work and the works of 1 through 3 and 7 through 9 has shown that dependencies measured in one and the same epoch of the year of the ether wind sidereal time have the similar character of the ether drift velocity variation within a day. At the same time, dependencies viewed of the ether drift velocity with sidereal time, the ether drift with sidereal time measured in different epochs of the year differ from each other. That can be noticed, for example, by the experiment published results of 7 through 9. The reasons of such seasonal variations has not been defined yet.
What could it be? Because, like, dude, it's just the Earth rotating faster, Toby. It's just sometimes you just gotta speed up and slow down, bro.
Oh, you know what it is? The Earth has its own retrograde, and that we just can't see it when we're on it because of reference frames. So, yeah.
That's a new one.
Right?
It
I
can be
don't disagree with it. Sorry.
it can be suspected
Yeah.
that. Oh, go ahead.
Yeah, sorry. Just wanted to let you know you guys are doing great. I'm gonna take off, but keep on going, guys.
Heck yeah.
Peace, bro.
Thanks for the good words.
Later,
Kind words.
man.
We will keep going. It can be suspected that magnetosphere, at its considerable sizes and peculiar shape, ionosphere, the known variations of their state, can be responsible for such dependence. Ooh, you're talking about those spheres, those concentric circles of ether wind.
Where's that?
Relating to the sidereal time right here in the magnetosphere. It's like, yo, right after he talked about how it has not been defined yet. Yeah. Yeah, you might be talking about some
Hang
big
on, sorry.
physics
Okay.
questions.
It can be suspected that the magnetosphere, at its considerable size is and peculiar shape, ionosphere, that the variations of this state can be responsible for such dependence variations of the ether wind and sidereal time. So he's saying the ionosphere and the magnetosphere might be deflecting the ether wind in some degree. Is that what they're saying? Is my mic on?
Yeah, I think you're right.
Okay.
It's pretty
Okay.
interesting.
Yeah. It's that pear-shaped magnetic field, man. It's
Yeah.
interfering with that ionosphere.
Hey,
So it can be seen in the figure 8. The ether drift velocities measured in each of the experiments differ. That can be stipulated by the arranging height differences of measuring systems above the Earth's surface. 1.6 meters, 42 meters, and 1830 meters. The collection of such data illustrates the height effect development. In the work, the ether drift velocity measuring have been performed at the heights of 1.6, 4.75 for the height dependence discovery. In the table 2, the mean variable or the mean values of the ether drift maximal velocity are given, which are measured in the work in the experiments of 1, 3, 7, 8, and 10. In these four experiments, the measurements are performed at 5 different heights: 1.6 meters, 4.75 meters in the work, 42 meters in the experiment, 265 meters, and 1830 meters. Cleveland and the Observatory Mount Wilson accordingly. In the experiment, the measurements were carried out also in the Observatory of Mount Wilson. However, in contrast with the experiments of 7 through 9, which is carried out in the light wooden house, experiment 10 is performed in a fundamental building of an optical workshop of the observatory. It can be supposed that the ether stream breaking by the house walls was the reason of the ether drift velocity smaller value measured in the experiment 10 in comparison with the experiment result of 7 through 9. The table 2 gives the imagination about the ether drift velocity variation in height band above the Earth's surface from 1.6 meters up to 1830 meters. Ooh, this is interesting. Okay. In the figure 9, this dependence view is presented in the logarithmic scale. Whoops. Whoa, whoops. Come on now. What?
Highlighter broken?
I don't know. I guess so, man. There we go. On the abscissa, the ordinate axis logarithmic values W over W star and Z over Z star were pending accordingly, where W is the ether drift velocity at the height of Z. The values W star and Z star are considered equal to 1 meter per second and 1 meter accordingly. Okay, so where is this whole figure 9? Because it looks like, so basically it looks like he's trying to take into account viscosity on Mount Wilson walls.
Yeah, he's trying to derive like a gradient across the globe, right? That global gradient.
So meters per second, 10,000. It's not that different. Is it? I can't recall. That's pretty much the same. Or no, he had 8,000 before. He bumped it up by 2,000, right?
Yeah. See, that's the thing when you when you
I'm
go
saying
over.
because he's
Yeah.
accounting for the walls now.
Oh, is that?
Yeah, that's what he's
Well,
saying here. In contrast, was carried on a light wooden house performed in a fundamental building of an optical workshop. It can be supposed that the breaking by the house walls was the reason. And so table 2 gives the imagination about the ether stream variation of height of the Actually, I don't know. So this is table 2. What is figure 9? Wait, we didn't look at figure 9. Depends on the ether drift velocity on the height above the Earth's surface. Is this work experiments? That's the. Oh, so yeah, this says meters per second. Or kilometers per second, rather. And then kilometers. There you go.
No, altitude in kilometers.
What did I say?
The same thing twice.
Oh.
What did I say? Just fucking, you made a sound with your mouth. I don't know.
Yeah, altitude. Yeah, z over z is altitude, and then
That's
the
what I meant, yeah.
other
My
one is
bad.
the speed.
That's awesome.
Cool. Well, yeah.
So yeah, there's a linear. So does that look like a linear
A linear
relationship, dude?
to
A
the
linear
height.
graph.
A linear deviation depending on the height relative to the height. The further up you go, the faster it gets, or what?
Yes.
Directly
would be-
relational to an orbital
Oh,
component.
it's weird when they
Or
keep
two-
lining up exactly like how we need, right? Feel bad for them.
I mean, it's dope for us, right? But
Right,
like,
I mean,
not
it's
so
really-
good for the.
It's really useful when everything keeps lining up, like you barely even have to do anything.
Has to line up.
Direct relationship to the translation of the motion of the sky.
Exactly.
Or else they'd have a stencil or an arc,
I wonder why they hit all this, dude. And like, I wonder why Dayton Miller died a quiet death, and then he was awful, and nothing mattered. And they brought out all the new stuff.
So we are here. It can be seen from figure 9 that the different experiment results are near one straight line, and in height band from 1.6 meters up to 1830 meters, the ether drift velocity increases with the height grown above the Earth's surface. The boundary layer has considerable thickness that can be the consequence of the ether stream and the atmospheric interaction. Boom, highlight. These data do not contradict the imaginations of the Model 4 through 6 about the viscous ether and its stream near the Earth's surface. From Table 2, Figure 8a, and Figure 9, it can be seen that the ether drift velocity is rather small near the Earth's surface. That can explain the reason of zero results of many experimental works, in which the value of 30 kilometers per second was taken as the ether drift anticipated velocity. In such experiments, the metering device sensitiveness was obviously poor. With the expression, it can be calculated that the ether drift velocity of 200 to 400 meters per second, the methods of the second order almost are inapplicable for measurements. Real quick. With the expression 1, it can be calculated that the ether drift as in the case such measurement sensitiveness to the ether drift velocity is low in 6 orders than the sensitiveness of the first order methods. The ether kinematic viscosity has been measured in the work. The measurement results are explained above in the part result analysis of the interferometer tests. That is stipulated by the peculiarities of the experiment implementation. The measured values of the ether kinematic viscosity are in the limits. VEA is approximately 5.5, iterating up to 7.1 times 10 to the negative 5 meters squared per second to the negative 1. The mean value is equal, VEA equals to 6.24 times 10 to the negative 5 meters squared per second to the negative 1, that according to the value coincides with the ether kinematic viscosity value calculated above. VC is greater than or equal to 7.06 times 10 to the negative 5 meters squared per second to the negative 1. Hence, the differences between the dependencies ether wind or sidereal time and the ether drift velocity measured values available can be explained by the measurement method differences of the work and the experience of 1 through 3, 7 through 9, and 10, and differences between arranging heights of measuring systems. The results of 4 experiments do not contradict each other that illustrate the reproduced measurement nature of the ether drift effects in various experiments performed in different geographical conditions with different measurement methods applying. Boom.
So Miller reproduced with different apparatuses, different locations, different materials, etc., yet the fluctuations are measured the same when you plot them against sidereal time.
The mean daily
But,
course of the
dude.
ether drift velocity.
Nice.
Oh.
Temperature, though, you guys didn't account for temperature clearly. So, do another 5 million. That's obviously what's causing the deviation exactly in line with the sun each time. So,
The periodicity that just happens to match up every day is just totally random. Trust us, it's just temp.
and it consistently random. Yeah, like into the 7 order of 1,100,000 times to the odds. It's definitely not the ether drift, that's for sure.
According to the original hypothesis, the ether drift velocity horizontal component, ether wind, should change its value with the period per one stellar day. The space effect. Let's make this blue. For revealing the ether drift velocity component with such period, the results of systematic measurements were subjected to statistical processing in stellar timescale. The results of such processing are shown on the figure 10. On the fragments of figure 10, the stellar time, sidereal time in hours, is suspended on the abscissa axis. The ether drift velocity value, ether wind in kilometers per second, is suspended on the ordinate axis. The vertical hatches indicate the confidence intervals. In the figure 10a, the mean daily course of the ether drift velocity within a stellar day, ether wind sidereal time, is given. This dependence is calculated according to the measurement results of the work which were performed during the 5 months of the year since September 2001 till January 2002. During 5 months, the numerical value of stellar time shifts regarding the solar time is in 10 hours, or regarding to the solar time in 10 hours. Since September till November, the measurements were performed on the point number 2, in December and January on the point number 3. The mean values are calculated with the expression 43. For comparison, in the figure 10b, the mean result is given, which was obtained in the experiment 1 through 3 during the year's 5 months at the same name, since September 1998 till January 1999, here as contrasted to the similar figure given in the works of 1 through 3. The measured value is expressed in the ether drift velocity values. Yo, what are these, man?
What are these? The equinoxes.
No, but 98 and 99.
Oh, that was when he did his measurements.
The ones from the 2001 paper, is that right?
I think so. Or no,
Okay.
he did. Well, his 2001 paper was about his 1999 and 1998 measurements.
Oh, so 1 and 2. Dude, we need
Oh,
1
yeah.
and 2.
No, we have those. Right?
We have 3.
We're reading.
Whoops.
Oh.
We have 3, I think. He probably talks about this in that book, right? About both of these?
Yeah. Yes. Because it's like a summation of both of them. And I only read like halfway through the review of this one that we're reading now.
Experiment in the band of radio wave. Ether drift effects and experiments in radio waves propagation. Ethereal wind and experience of millimetric radio waves propagation. Come on, come up with
Yeah.
some Because then they get translated, and it's like I can't tell which one's which.
I don't know how many synonyms are in this fucking sentence.
Yeah. So yeah, I think it would be nice to get those original papers.
Well, you know, the people that usually provide when the community doesn't have them is you guys. So I mean, we can hope for the best, or you know,
We've been trying.
yeah.
We
So,
found some other
you,
more recent stuff that was pretty interesting. So
do you remember when we weren't sure about Etherwind, and now we have like an overabundance of fucking already previously done, reprised, highlighted experiments? It's like, oh, we couldn't find enough evidence for the ether, so
And now we can't stop finding it.
yep, it's true. Here, as contrasted in the similar figure given in the works of 1 through 3, the measured value is expressed in the ether drift velocity values. In the works of 7 through 9 and 10, such data miss owing to smaller uncoverage of the year's epochs of the measurement statistics in these experiments. Both fragments of the figure 10 as a whole have similar nature to the ether drift velocity variation within a day. The differences in the curve shapes can be explained by viscous ether stream interaction with the terrain relief elements, which in these different experiments had the distinguished performances and features of the radio frequency spectral line arranging on terrain in the experiment. On the fragment of the figure 10a, this work, as contrasted to the result of experiment 1 through 3, figure 10b, the ether drift velocities have similar values that can be explained by the height distinction of measuring points in these experiments. The dependencies of the ether drift on the sidereal time have forms of periodically changed values with the periods equal to a stellar day that can be explained by a space galactic origin of the ether drift. Boom. Boom.
Yeah. The dependencies of
No
the
way.
average speed of the ether wind when plotted against sidereal time have the forms of periodically changed values with the periods equal to the stellar day. Yeah.
That's a lot of words for saying they matched exactly. It's like, who the fuck are you talking to, guys? Anyway, like,
Word salad.
like you're talking to your buddy. Like, dude, if I use a lot of big
Your
words, I'm gonna
buddy.
impress
Yeah.
his head. Like, you know what I mean?
Like, Shane, tell me more about these dependencies.
Like,
you-
if I
you're
could
working with.
pump in as many descriptive words to impress Alan, I'm like, wait, what am I doing?
You want to take over,
All
Alan?
right. Yeah, I got you, Brody. All right. So in the work, the observed band's offset direction of the interference pattern corresponded to the ether drift northern direction at the measurement implementation. Hence, the results of the work do not contradict the experiments of 1 through 3, 7 through 9, 10, and the imaginations of the work of 4 through 6 about the northern position of the ether drift apex that demonstrates the reproduced results of a nature or reproduced results nature of. Am I reading that wrong? Demonstrates the reproduced result nature of the ether. I don't know. The ether drift effect of the measurement and the different experiments performed with different measuring methods and application. So again, reproduced under different circumstances and different apparatus.
Yeah. Crazy.
Alright. In the work, we shall be confined to the qualitative comparison of the work results of the experimental data of 1 through 3, 7 through 9, and 10. For conducting a quantitative comparison analysis, it is necessary to specify the ether drift apex coordinate values on the celestial sphere. For the first time, we determined in the experiment 7 through 9 to specify an analytical view of the ether drift velocity dependence on the height above the Earth's surface proposed in works 1 through 3 to elaborate the calculation method of the terrain relief influence on the ether streams reforming near Earth's surface to determine probable influencing of the Earth's magnetosphere and the ionosphere that is subject to separate investigations and goes out of the frame of work problems. Due to this reason, the experiment results, the experiments of 1 through 3 and the experiments of 7 through 9 are given without any corrections, though its usefulness at the result comparison of the different experiments is quite obvious. Thus, in the work, the hypothesis experimental verification about the ether existence in nature, i.e., material medium responsible for electromagnetic propagation in optical wave
Green.
bands, has been performed. Dude, I was thinking the same thing. I was like, how can I get another joke in there about that? And I'm glad you said that.
Said it so many times in this paper. Sorry to interrupt.
I was about to say, hey Toby, what's that medium responsible for the electromagnetic propagation of waves in optical
that
in the optical
material medium?
wavebands? Yeah. That viscosity one that was measured down to the millimeter accuracy with radio wavebands.
Viscosity one? You mean viscous?
Yes, the viscous one. Yes, that one, the one that Shane said. All right,
The
let's see here.
viscous one, yeah.
Yes. Let's see. All right, so the medium which is responsible for waves to propagate in the optical waveband has been performed. The estimation of the ether kinematic viscosity value has been performed. The first order optical method for the ether drift velocity and the ether kinematic viscosity measuring has been proposed and realized. The method action is based on the development regularities of viscous liquid or gas streams in the directing systems. The significant measurement results have been obtained statistically. The development of the ether drift required effects have been shown. Yeah, can you highlight that one too? The development of the ether drift requirement effects. Because remember, there was like a whole, there was like 4 criteria or whatever that he laid out. So the measured value of the ether kinematic viscosity on the value order has coincided with its calculated value. So wait, Toby, are you saying if you have a prediction and you like do an experiment, you measure it, like that your prediction was confirmed or whatever?
Earth ball go spin. I think pretty sure this guy's wrong. This is no peer
Okay.
review.
Oh yeah, that makes sense.
Stop talking about methodology and results. Let's just
Dude, this dude measured something that was falsified in 1887 by Michelson Morley. What a nerd. The velocity of the optical wave propagation depends on the radiation direction and increases with height growth above the Earth's surface. The velocity of the optical propagation changes its value with the period of one stellar day. The detected effects can be explained by the following. 1. The optical propagation medium available regarding the Earth's movement. 2. Optical wave propagation medium has the viscosity, i.e., the feature properties of material medium composed of separate particles. 3. The medium stream of optical wave propagation has got a space galactic origin. The work results comparison to the experimental results executed earlier in the order of the hypothesis. In the order of the hypothesis, verification about the existence of such a material medium as the ether in nature has been performed. The comparison results have been shown. The reproduced nature of the ether drift effect measurements in various experiments performed in different geographic requirements. What different measurement methods, applications, whatever. The work results can be considered as experimental hypothesis confirmation about the ether's existence in nature, i.e., material medium responsible for
Drake.
electromagnetic. Yeah, dude. By the time we're done, we're dead.
We did it.
We did it,
How long did
ladies
that take?
ladies and gentlemen. We did it, or whatever. LIGO, yeah, yeah. Don't worry.
It only took us 3 or 4
that was a quick-
hours.
3 hours, not bad.
Dude,
Not nearly as long as the last paper. We spent a lot more time going over things last time, I think.
Yeah.
But this time we knew what we were in for.
Yeah, I could tell you were taking your time when you were fucking strawing out the words to torture yourself for fun or something. And you were like, I don't. No, I'm just kidding. Dude, like, what do I knew that Lindsay wasn't gonna finish in time to be able to take part in this, but this is the second night that you decided to get together and read PDFs aloud to each other.
Yeah.
I'm joking,
and
but
anyone
that-
willing to listen.
Dude, honestly, we should do that every week because to listen to people read that can't fucking pronounce words and stumble is embarrassing to everyone. So we should all be able to fucking publicly reread. And the only way you get it is if you fucking read a lot and practice and like, say it to your friends and try different tones and, fucking play with it.
Yep.
Otherwise,
Learn
you'll
every
just be
time we
like
read.
dry riff and not know how to read and you'll be so fucking embarrassed.
And then Eric pops in the background and explains the math to us, and it's
Right.
awesome.
Right.
Dude, it all works out. You just trust fall into Eric.
Who
Just read the equations.
did you
to
trust fall? That was it a bungee jump the other day? You right off by
Oh,
yourself?
dude, I trust fell into Toby, and he was AFK.
Yeah,
I was like,
Toby,
Toby,
you
you
here?
there? Yeah.
Okay, good. I'm like, did you hear a yes or? I don't think he's no. Go ahead.
Well, hey,
it's
I'm
fine.
gonna wrap up the reading stream.
Yeah.
Sorry.
Oh, you're good. Thanks everyone
I'm
for
here.
tuning in and listening to the Galaev paper. Just to be clear, in case you just tuned in, I'm gonna have to patch some stuff together, but this was the measuring of ether drift velocity and kinematic ether viscosity within optical waves band by Galaev from the Institute in Radio Physics and Electronics of the NSA in Ukraine. Received on November 15th,
Fucking what a
2002.
G.
Again, thank you, and stay ethery out there.